The world has never looked this way before, whether in the sky, on land, or on the oceans. Gigantic man-made structures are today a part of our landscape. The world population is rapidly growing. We need higher houses, broader bridges. We want to travel faster and need to transport more and more goods. So, even larger, more complex structures are constructed. These have to withstand extreme climatic and mechanical strains and use a lot of energy. In order to manufacture these sustainably, without exhausting the Earth's resources, we are searching for new technologies and more intelligent solutions. Here, at the Fraunhofer Institute for Large Structures in Production Engineering. Welding, milling, programming. Specialists develop innovative products and manufacturing methods, from details like material studies to entire production workflows. For small-scale production of large structures, this is the leading research institute in Germany.
Innovations are inventions that are put into practice and use. And when one works here with this focus, then one can also have success in the industry. And this is what we see.
A manufacturer of huge ship propellers asks the Fraunhofer IGP engineers for advice. MMG is world market leader in producing propellers over 80 tons in weight. The huge workpieces are up to 12 meters in diameter and cast from a bronze alloy. The problem? In order to grind off the excess material and bring these propellers into perfect form, a worker has to first drill about 1,000 marking holes into its surface manually. The Fraunhofer researchers have an idea: an electrically powered, large-scale robot with a drilling application. But in order to drill markings onto all sides of the propeller, the robot must be extremely flexible. With big gears and joints, the team constructs an optimal kinematic chain. However, the larger the robot, the more difficult for it to work precisely. The team brainstorms the options. The engineers decide to develop a 3D tracking system, which with a point laser and sensors in the robot head, can determine its position to and distance from the propeller's surface, with absolute accuracy. A robot entirely designed and manufactured in-house. Nowhere else can one buy such a tailor-made, specialized robot. A machine of such a dimension is able to operate with millimeter precision, thanks to its flexible control technology, additional sensor systems and built-in tools. This robot can now take over a tedious manual drilling process, a true innovation in this context. It is programmed by the Fraunhofer IGP such that a trained worker can operate it independently. This large-scale robot was developed in close collaboration with the customer, specially designed for this traditional foundry. It is a very sustainable solution.
The large-scale robot is unique for us because it automates an important processing step in our company, and in this way our ship propellers are more precisely and flexibly manufactured.
This airline manufacturer also needs help. In the construction of aircraft fuselages, so-called stringers or longitudinal stiffeners need to be connected in the load-bearing structure. The material flow simulation shows that there is a bottleneck in this production chain. The manual riveting of the stringer couplings takes way too much time. A worker has to first drill through high-strength aluminium and then places hundreds of rivets using heavy pneumatic tongs, a physically very exhausting task. The Fraunhofer experts analyze the riveting process and work on an advanced technical solution for the aircraft manufacturer. In a virtual ergonomics simulation, they measure the stresses and strains on a person's limbs and joints while riveting. The red areas show extreme strain, especially when he or she stretches upwards or crouches down with a heavy tool in hand. So, what about designing a practical lifting aid, a hand-driven robot arm? In this way, a person could direct the robot arm, but would not be carrying the heavy load. And the new self-piercing riveting method also takes over an entire step. The manual pre-drilling is no longer necessary. The interconnected handheld system allows for immediate quality control. The result? A considerable workload relief and time saving in the final assembly. While placing a single rivet used to take about 5 minutes, the robot arm now only needs one.
Applied research hasn't had a very long tradition here in Mecklenburg-Western Pomerania, especially applied research for industry, so we are an institution that, at least in this part of the country, has a unique character.
Josef von Fraunhofer. This man paved the way. Research with practical relevance, not for the shelf. His discoveries in the 18th century lay the foundation for modern optical technologies. With self-made prisms, he investigated the spectral composition of light and revolutionized glass production. Thanks to his findings, streak-free glass could finally be produced for microscopes, lenses, or telescopes. Because of this inventor and businessman's exact methodological way of working, the Fraunhofer Society chose its name. The Fraunhofer Gesellschaft is the largest research organization and development service provider in Europe. With over 80 institutions, it is an important part of the German research sector. The Fraunhofer Research Institute for Large Structures is based in Mecklenburg-Western Pomerania, in the heart of Rostock city. This Hanseatic town in northern Germany stretches along the Warnow River up to the Baltic Sea. With the oldest university in the Baltic Sea area, it is a dynamic cultural and urban center, the most densely populated city in the region, characterized by its location at the sea. Here one finds Germany's largest cruise ship port, the port of Rostock, which is vital for cargo handling and many globally prestigious shipbuilding companies. A commercial center with maritime industry and leading technology institutions such as environmental or space engineering. And in the middle of it all, the Fraunhofer IGP. Founded in the year 2000, initially to support the shipbuilding industry, but today also many other future industries. Especially environmentally friendly research concepts are currently in demand. Nowadays, ships have to transport more people, more mass, and yet should consume less fuel. This is only possible if they become lighter. For this ship section, one develops an alternative building material to heavy steel, a lightweight structure made from fiber-reinforced composites. Millions of fibers, a light balsa wood core joined together by a resin mixture. The final component should not only be flexible, but also extremely robust. For better adhesion, the material surface is activated with a plasma beam. Contrary to metal, this material cannot be welded, so one selects an optimal bonding method. Every detail has to be extremely well thought out when thousands of people want to cross salty and freezing oceans. The final structural element is put to the test in a climatic chamber at -50 to -60 degrees. Other products can also be tested here, for instance in terms of corrosion in a salt spray chamber. This institute doesn't just concentrate on the final product, but on the qualification of the entire production process.
Through close collaboration between the individual departments, we are able to treat projects from the initial idea to the final prototype with a holistic view.
And qualified specialist engineers are right here on the doorstep. The Fraunhofer Institute is embedded in the science campus of the University of Rostock, in close proximity to departments like physics, informatics, or machine engineering. The institute cooperates closely with the professional chairs of production and joining technology, where junior researchers are trained. The students can gain practical experience and professional skills in the Fraunhofer IGP. Fresh, young minds are always welcome here.
We make use of their dynamism to bring new ideas and impulses into our teams. And if they aren't the employees of tomorrow, then they are at least the customers of tomorrow who will have profited from what they learned here. And in this way, the transfer idea lives on.
With less state funding for green energy, wind turbine manufacturers need an increased yield. In other words, larger wind turbines. A tower makes up about 20% of the total cost. In order to build it more economically, one has to begin with the details. Especially the quality of the joints has to be considered, as the larger the components, the more strain these will undergo. In a technical meeting, the engineers discuss how a wind turbine can be optimized. From material requirements like mechanical durability or resource efficiency to alternative joining elements like screws or lock bolts. The choice of joining technology is a central task as this substantially influences quality and cost. In order for the tower to withstand extreme wind forces, a high-performance welding process, such as submerged arc welding, is necessary. With high-resolution images from the welding cavern and with microscopic investigations, the welding seams can be analyzed in depth. Without fundamental research, there can be no applied research. One has to begin with the microscopic details if one wants to change gigantic structures. In an attempt to improve fatigue strength and service lifetime of a wind turbine, this self-constructed, component-like test specimen, or so-called L-flange model, is being tested in-house. The model is fixed into a testing machine and pulled apart. One observes how the joints behave under effective loads. Results gained by all specialized departments can always be transferred to other solving problem tasks for other kinds of large structures.
Depending on the design requirements, whether for a bridge, a car or a launch pad for an Ariane 6 rocket, we try to find the optimal joining technology solution for our customers.
Always open for visitors and clients. A place for the exchange of knowledge, creative thinking and new ideas. It is all about communication at the Fraunhofer IGP. Whether it be communication via fiber optic cables with clients around the world, one-to-one technical support, or between colleagues from door to door. Working together proves to be a good strategy, as the increasing customer demand and the positive order situation show. This research institute is made up by people who share their specialized skills and work together as a dynamic team, producing innovative results. With optimism, they work together to reach one common goal, which is to positively shape our shared planet and future.